Assalamu alaikum students. Hope you all are fine. You are listening to your chemistry teacher, Miss Hina Islam. Today we are going to study about chapter number 5, Physical States of Matter, page number 90 to 91 of your book, and topic is boiling point for ninth class. Whenever we boil a liquid in a container, the average kinetic energy of the molecules increase. Therefore, the temperature of the liquid also increases. Heating allows larger amount of the molecules at the liquid surface to overcome the attractive forces responsible keeping them in the liquid. This increases the vapor pressure of the liquid. Vapor pressure of the liquid keeps on increasing with the increase in temperature. It means vapor pressure of the liquid is directly proportional with the temperature. Whenever we increase the vapor pressure of the liquid, the temperature will also increase, and whenever we decrease the temperature, the vapor pressure will also decrease. At a certain temperature, the vapor pressure of the liquid becomes equal to the atmospheric pressure, or we can say that external pressure. At this stage, liquid starts boiling. Bubble of the vapors form throughout the liquid, rises to the surface and escape into the air. It means the standard definition of the boiling point is the temperature at which the vapor pressure of the liquid becomes equal to its external pressure or atmospheric pressure. Again, I am repeating, the temperature at which the vapor pressure of the liquid becomes equal to its external or atmospheric pressure, it is called boiling. Different liquids have different boiling. Every liquid have its specific boiling. In this picture, you can say that the vapor pressure is equal to the external pressure. Then there occurs boiling. The temperature at which this equality occurs is called the boiling point. Temperature is the average kinetic energy. In this picture, you can see boiling water. The bubbles starts from the bottom of the liquid and they goes up to the surface. In this video, you can easily observe the vapor pressure becomes equal to the atmospheric pressure. Here, it is the microscopic characteristic which usually occurs into the liquid. Whenever a liquid boils, the molecules attain the kinetic energy by their change in temperature. Now we are moving towards self-assessment 5.4. The figure of your book. Look at the figure in your book on the page number 90 has been given 5.9. You can see in this picture. We have to predict the boiling point. We have been given here 4 liquids. First is chloroform, second is ethanol, water and ethanoic acid. You can see red dots in this picture which indicate the boiling point. These are the curves for the 3 liquids. First, you can observe chloroform has a boiling point at the 60 degrees as the first red dot indicate. Second has 80 degrees. Ethanol, water boils usually at 100 degrees and ethanoic acid at 120 degrees. Now, there are some factors which affect the boiling. Whenever we boil the liquid, there are some factors. This is the topic of your book, that is 5.3.1, Effect of External Pressure on the Boiling Point. Liquids boils when their vapor pressure is equal to the atmospheric pressure exerted on it by the surroundings. The normal boiling point of water is 100 degrees, as you know very well. In the mountains, the atmospheric pressure is less than 1 atm, 1 atmosphere. So the water below boils below 100 degrees. In a pressure cooker at 2 atm, pressure increases, so water does not boil until the temperature reaches 120 degrees. Students, please note it. In pressure cooker, the pressure is 2 atm and water boils at 120 in pressure cooker. Okay. Normally, the atmospheric pressure is 101.325. And you can see in this one, here is a graph between external pressure and boiling point. You know, it is a straight line and it means external pressure is directly proportional with the boiling point. Here we have self-assessment exercise 5.5. The boiling point of water on the top of the Mount Everest is 70 degrees, while at the Murray is 98 degrees. Explain its difference. As we have discussed now, the difference between the mountain boiling of water and the pressure cooker. Now, whenever the atmospheric pressure is 1 atm or normally 101.325 kilopascal, water boils at 100 degrees at sea level. This is our standard condition or normal conditions. This is because at this temperature, vapor pressure of water is 1 atmosphere or 101.325 kilopascal. At Mount Everest, at about 8850 meters, 8850 meter above the sea level, atmospheric pressure is only 34 kilopascal. So water boils at the high level, sea level, when its vapor pressure is 34 kilopascal at 70 degree. So water boils at 70 degree. It means when there is a change in pressure, there is also change in boiling. At normal condition, water boils at 100 degrees, whereas at 34 kilopascal, water boils at 70 degree. Question number 2 is, if you try to cook an egg in boiling water while camping at an elevation of 0.5 kilometer in the mountain. Just suppose you want to boil an egg. So, at a height of 0.5 kilometer in the mountains, you will find that it reaches longer than it does at home. Explain why. Again, the same reason, when the pressure of the atmosphere is 1 atm or 101.325 kilopascal, water boils at 100 degree at sea level. This is because at this temperature, vapor pressure of water is 1 atmosphere or 101.325 kilopascal. At elevation of 0.5 kilometer on the mountains above sea level, atmospheric pressure becomes low. So water boils at this height above sea level when its vapor pressure is low at low temperature. That is why egg takes longer time to cook than it does at home. Eggs require more time because there is a low due to elevation due to 0.5 kilometer and change into the vapor pressure, external pressure. Okay. Take care. Stay blessed. Thank you.